post this video so you can see what a whiteboard looks like. All right, so we are doing number 7, trains. All right, so here's what it says. It says a train leaves Chicago heading north at noon at 20 meters per second. Another train leaves from a town south of Chicago, and it's somewhere south of Chicago, 20 minutes before the Chicago train left. That heads also north at 45 meters per second. And they meet exactly 1 hour later. So you got this situation. You've got, here's Chicago. This is where we're starting. Train 1 heads this way. Train 2 starts back here and heads this way even faster. And then they meet over here somewhere. All right, so let's write some things down. Let's call train 1, and train 2. All right, train 1, what do we know about it? Well, it leaves Chicago at noon, and it heads north at 20 meters per second. So that means its velocity is 20 meters per second. Notice I didn't say speed, I'm talking velocity now. Another train, train 2, leaves from a town south of Chicago 20 minutes before the Chicago train left. This is tricky. So what does that mean? If it leaves 20 minutes before the Chicago train left, what does that tell you about the amount of time that it's traveling compared to the amount of time that the Chicago train travels? Is it traveling for more time or less time?
Less time.
If it started 20 minutes earlier?
More.
More.
Oh, so more time.
Yeah. So we know this. If train 1's time is t, let's call it train 1, and I'm just going to call it t1, then train 2's time is like the first time's train plus 20 minutes. How do you feel about that? Anybody spotting anything that seems weird about this that we should deal with? I'll give you a little hint. Minutes. How do you feel about those minutes?
You have to convert to seconds.
You should convert that to seconds. Let's do that. So T2 is really T1 plus, how many seconds is it, you guys? You can do this.
1200.
All right, there you go. So we know that. All right, let me see if I can move this. That's not going to work. Okay, so now, what else do we know about train 2? It heads north at 45 meters per second. And they meet exactly 1 hour later. Aha. So wait, does that tell me anything about these T's? How long is train 1 on the road? Or on the tracks? If they meet an hour later. It leaves Chicago and meets the other train an hour later. So how long was it traveling?
1 hour.
Good job. 1 hour. How many seconds is that?
3600.
All right. So hey, does that tell us the time for train 2?
1 hour 20 minutes.
So it's got 3600 seconds. So this is 3600 seconds plus 1200 seconds equals
4800.
All right. In a whiteboard, they don't do this, do they? So I need more space. All right. All right. So can this thing get bigger? Oh, we can do that. All right. Awesome. Okay. So what are we ultimately trying to find? It says, how far south of Chicago was the second train when it left? How far south? What is it really asking for when it left? How far south was it when it left? Is it asking for the velocity? No. It's asking for the, how far was it when it left? Is that the change in position? No, that's not it. What might it be? What does that describe that we want to find?
Distance?
Well, we don't really mention distance so much anymore. How far south was it when it left.
Displacement.
Displacement is how far it goes. That's its final position minus its original position.
Okay. Is it the original position?
We're trying to find its original position. Where was it when it left? So we're looking for XO equals for train 2. All right. So I think that's all the information we have. Well, what do you know? If they're colliding, what do you know about their time and position? What's the sentence for a collision? At the same
Time.
They're at, all right, so do we have a final position equation for train 1? I would call it 20 meters per second times the time it's traveling, which is 3,600 seconds. You all right with that? You guys are quiet. This is for train 1. Do we have a final position equation for train 2?
It's 45 meters per second plus 4,800.
I'm going to say it's
times 4,800 seconds.
Plus what?
How far away was it when it first started? I don't remember.
Yeah, no.
Oh no, plus XO.
Plus XO.
Yeah, plus
That's
XO.
the equation that we always use. That's your y-intercept, right? Can you solve from here, you think? Can we set those equal to each other? We can. We can say that 20 meters per second times 3,600 seconds equals 45 meters per second times 4,800 seconds plus the original position. The algebra gets pretty straightforward at this point. 20 times 3,600 is 72,000, I think. And we know that the seconds goes away, so we're left with meters equals 45 times 4,800 equals 216,000 meters plus XO. So, do we do this right? Minus 216,000 meters minus 216,000 oh, what just happened? There we go. I don't want this. 216,000 meters. And there's a 0 on there that's not showing up. All right, so when you do this, 72,000 minus 216,000. This is weird. I get this negative 144,000 meters equals XO. Does that make sense?
Yeah, because it was south.
It was south. Beautiful, thank you. So because it was way south of Chicago, how far south was it? It was 144,000 meters south of Chicago. You guys know where that is by any chance? It's right around Gary. Okay, so there's the steps, my friends. I'm going to stop. Go back. How do I get out of there?